Hey everyone, in this video we're going to do one last application, one last word problem that involves graphs of transformations of sine and cosine. So this is sort of similar to the Ferris wheel. If you are feeling good about problems like that, this would be a great one to pause and try on your own. Okay, so in this one we have a clock hanging on the wall. The tip of the minute hand is what we're interested in. So we have this clock and the minute hand is going around and around, and we want to follow the height of the minute hand as a function of the time in minutes. We know the minute hand is 15 centimeters long. The middle of the clock face is 185 centimeters above the ground. And we're supposed to graph and find the equation. I wasn't very specific here. Let's say that t is time in minutes. Did I not say? Let's say we're starting at noon. Okay. So this is just so that we know if we're starting. Sorry, too many yawns at night. At the top of the clock or the middle or the bottom. So if we're starting at noon, we're starting at the top of the clock. Okay, so we know that the minute hand is 15 centimeters long, and we know that the clock face is 185 centimeters above ground, the middle of the clock face. So this is what we're trying to translate over here. So let's just make this ground. And the very top of the clock is going to be 185 plus 15, so 200 centimeters. Okay, so let's see if we make this. That's not going to work. We make them 20, 40, 60, 80, and this would be 100. 20, 40, 60, 80, 200. Okay, so my tick marks are 20. So this is going to be kind of little. Okay, so this is 180, and this is 160. Okay, so we're starting at t equals 0. Go ahead and draw an axis in now that I've marked all of those. All the way up at the top, 200, and then it's going to take, so this is minutes, it's going to take 15 minutes before the minute hand is pointing straight out over here. So let's look at a full hour. So let's say this is 5, 10, 15 minutes, 30 minutes, 45 minutes, 60 minutes. Okay, so you can scrunch that down more if you want, but we made 5-minute tick marks in this one. So starting from the top, after 15 minutes, I've gone a quarter of the period and I'm at equilibrium. After another 15 minutes, the minute hand's pointed straight down. So I'm at the bottom. Oh, and I wasn't being careful here. This should be slightly higher. So this is 15 minutes back to a height of 185. This was 0, 200. And then after another 15 minutes, I drop 15 centimeters. So I'll end up at 170, which is right in the middle. So there's, 30. I'm making a mess of this one. 170. This is why I don't normally do these in permanent marker, but it shows up so nicely. Okay, so 45 minutes we should be back up to equilibrium, and then 60 minutes we should be back up to the top. So this is fairly shallow looking with our scale. It's really only supposed to hit the second one. So you could absolutely scrunch it down a little bit this way if you wanted to, make it look a little less flat. You could also truncate your axis, and you could only look at, say, 100 to 200 or something like that. But that's a perfectly fine picture. And then the other part of this would be to find the equation. So once again, you get to choose between a sine and a cosine. I would choose cosine again here. The graph starts at a maximum, so cosine I won't have to flip or phase shift. Okay, so for cosine, I want the amplitude to be the 15 centimeters. That's how far I go up and down from the middle. So 15 cosine. I want the period to be 60. So if I take 2 pi and divide it by 60, I get a pi over 30. I'm not shifting, so I'll just put a t in there. And then I'm not shifting horizontally. I do want to shift vertically. So the equilibrium, the middle of the clock face is the 185 centimeters. So this is my formula. I could also use sine, and if I was going to use sine, you could try and line up, excuse me, with this equilibrium point, but you need to flip sine upside down if you want it to go down from here. So if you're trying to take that normal equilibrium point on the y-axis, you'd want to flip and shift to the right by 15. You could also shift it left 15, so then you're coming back up from there. So there are some choices, but I think cosine is the easiest. All right, thanks for